In part 2, we're adding a topic to our initial list. We're adding the Doppler shift, which I accidentally left out the first go around. The symbols used in the Doppler shift, there's Fs, which is the frequency of the source, and there's Fobs, which is the frequency of the observer, i.e., what you hear. And then there's VW, which is wave velocity as always. And then there's Vs, the velocity of the source. Let's put all this in context. So here you are, you're a person Y or a person X, and the velocity of this vehicle is towards you if you're over here and away from you if you're on the other side. So the velocity of the vehicle is that way. All right, let me change colors, make that a little clearer. That way. So there's some Vs, the velocity of the source of the sound. And you can see what's happening here. As the car moves along, it's following here the sound wave out in front of it. And so by the time they reach the listener in front of it, where it's going, these are closer together, which makes their frequency higher. On the other side, the car is moving away from the sound wave as it moves. And so those sound waves are being spaced out further, which drives the frequency down. And so when you're calculating the frequency the observer hears, it's important to know which sign to use on Vs. Here's the equation. The frequency observer hears is the frequency of the source times the velocity of sound, or the velocity of sound plus or minus the velocity of the source. Well, if the source is moving towards you, use the minus sign, all right? If the source is moving away from you, so over here it's the minus sign, and over here it's the plus sign. The source is moving away from you, use the plus sign. Think about it another way, all right? Think about it another way. You know the answer to this problem. You know that if something is coming towards you, the frequency is gone up. And when it heads away from you, the frequency goes down. You can imagine this easily from any siren you've had go past you where it goes, wah, 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 wah. All right? So what does it take to make this number smaller? Well, this number gets smaller with a plus. That's going away from you, right? Because the denominator then is bigger, making this number smaller. On the other hand, if it's coming towards you, you know it gets bigger. You need the minus to make the denominator smaller so that the overall number gets bigger. Let's move on and look and see what happens if the person is moving, right? So now the observer is moving. The equation is different. We've got VW plus or minus V observed over VW. The principles are the same. If you're the observer running toward the car, you're running into sound waves as they come towards you. That means you need this plus sign here to make the numerator larger so that the frequency you observe is higher. If you're running away from the sound waves. They're having to catch up with you. The frequency is going down. That means you need this minus sign so that the numerator is smaller. And if we put it all together into one picture, we have the car moving, we have the observers moving. It is a combination of the two equations where you simply got the frequency of the observer is the frequency of the source onto the velocity of sound plus or minus the velocity of the observer divided by the velocity of sound plus or minus the velocity of the source. And the sign conventions are exactly like they are in the other two pieces. I've just written them a little differently, give you another look at them. All right, that's it for part 2 on Doppler shift. Enjoy the problems.